So good morning everyone. So this is operation research class. Okay. Uh, what we are going to do today is about actually game theory, but this is the introduction for that. Okay. So we call this group decision making. So you can follow this slide in Lentera, right? So first is disclaimer, okay? So this is very deep, and what I'm going to present to you today is like a scratch in the surface only. Okay? There are several Nobel Prize winners based on group decision theory alone, okay? Including the one that we will discuss today, arrow impossibility theory. So, and I don't know if we have time today. If not, next meeting about game theory. Also, there are several Nobel Prize winner on game theory. Okay, so this is really very active research. I'm also doing certain research in this area, but yeah, if you are interested and you would like to do some thesis, for example, instead of internship in the company, but you want to do some research, of course, you're welcome if you want to do thesis. Nah? Okay, so this is the overview, what we will discuss in this slide. So we talk about the power in group decision, and then we talk about aggregation of judgment, and we will practice Delphi method. And then there are many aggregation technique, and I think at the end of the day, I will discuss about voting, election, okay, and then person cooperative games. Okay. Okay, let's start. So this is what we have discussed so far, right? So we have decision under uncertainty, under certainty, under risk, under utility. Okay, up to this point, what you have learned is actually only individual decision against nature, right? So decision under uncertainty, under risk, under utility is all between you and the nature. Right? Now, when we start to do a game theory, start from today with this group decision making. So this is not just you, but you with your other teammate. Yeah? So today is about cooperative. Okay? Next slide is about decision under conflict. It is also game theory. Okay? Today is also cooperative games. Okay, so let's talk about group decision. Okay? And this is very important topic, right? Because based on group decision, we created a lot of things. So we created country, we created money. I mean, we is human. Right? We created what this called corporation. Okay? All of these are abstract concept. Okay? It's a shared idea that accepted by majority, then it become kind of consensus, then usually binding for the member in the group. So now most technique in a group decision is to use vote. Okay, so those who lost in vote must comply even if they do not like the decision. Right? So my question is this: what if those who lost does not want to comply? Does the group or the leader has the power to force them to comply or not? Okay. Is there, if there is no way to force them to comply, then those vote is actually meaningless, right? So behind the scene, okay, we talk about voting, we talk about a lot of technique here. You need to know that behind this scene is the real power to enforce that voting. So you are in Indonesia, so right? Which part of Pancasila is dealing with this voting? Livy, I couldn't see you.
Yeah, sorry, I couldn't turn on my camera because my bandwidth is so bad.
Low, okay. So,
Yeah.
which part of you learn about what is that? Civic, right? So basically Pancasila from kindergarten probably until now. So which part of Pancasila is talking about group decision?
Uh,
The
the fourth one
The fourth one. What does it say in English?
in English.
Yes, of course in English.
It's basically democracy.
You see it?
So correct in English. I never
In
thought of
English.
Pancasila in English.
Oh, you need to explain that because one day you will go out and talk about it as an Indonesian. You need to be responsible for your your own philosophy in the country. Oh, tell me, one by one. Joy first or Leafy first? I think this is important. Joy, Joy.
Uh,
Suddenly thinking about it.
yeah, I never thought of Pancasila for so long already.
Right. Okay, tell me about it. Uh, Explain as if I'm a foreigner, so I don't know. And what do you mean by the fourth uh, rule of Pancasila?
Okay, so the fourth rule is
In your own opinion, that's fine.
okay. In my own opinion, it means like basically the whole country will make decisions using democracy. So they will have like deliberations amongst the representatives that is already appointed by the uh, masyarakat society in Indonesia.
Okay, so you're talking about um, democracy in terms of how do you define democracy there?
So like we vote for presidents, even for all representatives, like from the even from the like smallest organization, even like our RT/RW. It's basically our like small neighborhood
Okay, so
district. We use voting as a decision making method.
is it voting really?
Oh wait, RT/RW. Yeah, it's sometimes someone appoints, but mostly it's voting in most areas.
Okay, okay. So there are some a lot of hole there, but anyway, let's hear Livy first. Livy, what is your understanding of the fourth rule in Sila in Pancasila?
mm,
I cannot see you, so you need to speak louder.
maybe about like the
Hmm?
wait, rakyat tuh um,
Or it's just your opinion is fine. There is no right and wrong.
wait
You learn this since kindergarten, isn't it? Every year.
yeah,
Yeah.
but I never thought it in English. Wait,
Yeah, I don't think any Indonesian has a like rarely
yeah.
someone thinks about it in English. We just think about
Okay.
it in Bahasa and like, yeah, that's
Okay.
basically it.
Vivi, tell me, what is your understanding?
Yeah, it's just like a democracy which is led by the wisdom in deliberation. Uh,
So democracy that is based on representative, that is the one that,
yeah, uh,
well, okay. Actually, the word, the important part there is actually not democracy. There is no democracy in those saying. Okay, it said musyawarah mufakat. Musyawarah mean meeting. Mufakat in English mean consensus. Okay, so that mean in Indonesian point of view, you need to reach consensus first before you do voting. That's the meaning. Okay. So reach the consensus first before you do voting. It doesn't avoid voting, but you need to reach the consensus first. So what is consensus? Mufakat. What is that? Can you explain?
Consensus is mufakat, or consensus is basically an agreement between everyone. So like
Right.
if you mufakat, then means you agree. Everyone's agree.
Everyone agree. Okay. Good. Good. Oh, you passed the. So let's come back to the slide. Yeah. Excellent, John. Everyone agree. Okay. So now my question to you. Okay. If everyone agree, right, then the agreement is binding. Correct? Is that correct? Say you make a meeting. Okay. Example, you make a meeting, and then in that meeting you agree on something. So is it binding for all members in the group? Yes or no? Yes. So now you do voting instead of consensus. Okay, you do voting. Okay, so say 7 out of 10 win, right? Is this the consensus or not? Say, for example, you have 10 members in the team, okay? And then what is the meaning of majority in here?
Bigger number of people who agree.
Yeah, how much? How many?
Bigger group.
Of 10, how many is called majority?
6.
6, okay? Half plus 1, right? So be half plus 1. So 6. 6 is already majority. So if you said, okay, based on majority win, then 6 is enough. But now you have 7. Okay? 7 out of 10 vote. So is this a consensus or not? My question. Still majority win, or it is a consensus? Or consensus must be 100%. 10 out of 10. What is mufak?
In the end, everyone must agree.
At the end, everyone must agree. But that means your consensus is 100%.
Yeah. So if, for example, if we even take the vote of like 10 people and 7 agree, 3 does not. But if in the end the 3 finally like, oh, okay, okay then, or like they come to some sort of agreement, then it's a consensus. But then if the 3 doesn't agree, like, oh, they're like mad or something,
Uh-huh.
then I don't think it's a consensus.
Okay, so the one that lost must comply, right, with the decision. that is the one that you said as consensus, right? So, but how if, I'm asking, how if they say they got mad and they don't want to comply?
Yeah, like in the PPT, either force them by like giving them consequence or just like.
So, okay. So I give an example here, the next slide. Okay, so this is my project several years ago. So the leader at that time, okay, the background is like this. There is a 3 years project. Okay, every year there was an evaluation. Okay, and we are in the second year at that time. So we will finish the second year, but the project was delayed, and that project consists of mini projects. So I'm one of the leader in the mini project. Okay, so now the project can push if all the mini projects are already finished. Okay, for the next stage. So the second year will finish in February, for example. Okay, so that we can start the third year in March, right? That is one choice. Or we will finish the second year in March. So we delay 1 month. Okay, but at that time we are not sure when we will start the third year. Okay, because at that time we will have another what is called general election in the country. So the budget may get delayed if we further delay just 1 month. Okay, so at that time, because of that reason, so 7 vote for February to finish, and then 3 said, okay, I will vote in March, saying that they cannot finish in February. Okay, now the question is, at that time, the leader has no power to force them to finish earlier, right? Because they said, I cannot finish this project. So then we know that the project cannot finish unless all members of the mini project have to finish it. So in this case, my question, who win the vote? The 3 who vote for March or the 7 who vote for February?
I still think it's the 3 because they cannot finish what no matter what they do they cannot finish. So
Yeah,
what can they do now? Like the 7. So it's
exactly.
like the 3.
So correct. So it's not the matter of vote, okay? It's the matter of power behind the vote that matters. Okay, you understand that? So when we discuss today, okay, we will try to create the weight on the vote, okay, so that this will represent the actual power. Can you see it? When we think about voting, usually we put vote with the equal weight, isn't it? Right? So, but today we will discuss, look, the real things in the voting is not the actual vote that we say, but the actual weight of the power. Can you understand the meaning of this? Okay? Okay, so the idea, okay, of what is called group decision, okay, the terminology is called group choice or social choice. You can search in Google, social choice, okay? So basically, this is an aggregation function. Okay? Mathematically speaking, this is just an aggregation function. Okay? What is that function? We don't know. There are many functions. Okay, so some people say Kenneth Arrow will tell this as social welfare function. He call it. Okay? It's an aggregation. What is aggregation? From individual preference, okay, you aggregate into social. So the micro level, in the micro level, okay, individual, right? Individual preference. And then on the macro level, which is the social choice, the group decision. So we create a function, whatever function it is, you can create on your own, basically, okay, that will aggregate or combine this individual preference into the group. Okay? So with that, then you can create what is called group decision. So mathematically speaking, group decision is just an aggregation function. Is it clear? Okay, so we discussed about it a while ago. So consensus is an agreement, right, made by the group that ultimately, okay, lead to a collective decision. Okay, so as you mentioned earlier, so the concept of consensus is often defined as 100% agreement, unanimous decision, right? Okay. So unless everyone agree, we don't have actionable decision. Okay. But actually consensus is not the same as unanimity. Okay. So yes, when there's a consensus, everyone agree on something. For example, you want to go to movie with your friends, right? Okay. So then you need to reach a consensus. Okay, which movie everyone want to see, isn't it? Otherwise, you cannot watch that movie. Okay, so we can say consensus is kind of strong consensus that occur when the opinion, okay, it's shared widely throughout the entire population. So it's not necessarily unanimous. Okay, so it's above the majority. Okay, majority means 50% plus one, right? So consensus is supposed to be above majority. So when we said 70%, maybe 80%, 90%, that should be consensus already. Okay, not necessarily unanimous. So unanimous is 100%. Is it clear or not, the terminology first? Okay, so given any set of individual preference, okay, that aggregation function, okay, will determine a particular aggregate of social ranking. So there is a problem that observed by, say, Marquis de Condorcet. This is about 18th centuries. Okay. Example, here I have 3 individuals. Okay. And there are 3 alternatives, X, Y, and Z. So X is probably want to watch movie, X, okay, okay, and Y is another name of the movie, okay, Z is another name of the movie. So, and these are the individual preference. You look at this, Ali, Buddy, and Cherry, okay. So, if you look at this X, which one is, comparing X and Y, which one is the majority? Here X is higher than Y, right? For Ali's case. For Cherry's case also, X is higher than Y. So, but for Buddy, no, Y is higher than X, right? So in that case, if you take majority of X and Y, X is winning, correct? Oh, how about the Y and Z? So comparing Y and Z, which one is winning among the 3?
Why?
Oh, because Y have 2 votes, right? Huh? Higher ranking, yeah? Right? Y have higher ranking of the 2 than Z. Oh, how about this one? Okay, we already compared X, Y, and then Y, Z. How about X and Z? Between X and Z, which one?
C.
Oh, then it's inconsistent, isn't it? a while ago we said x is higher than y and y is higher than z. Now you said z is higher than x. So it's not transitive, isn't it? So then we start to understand that there is a problem here. What? The problem of inconsistency. Okay, so this is a paradox. Okay, let's say the simplest way to aggregate. Okay, so it's called simple aggregation. So this is a simple function. So each charge, each voter, in this case, yeah, have an equal weight. Okay, so it's an equal weight voting. So there's an assumption here that individual is unbiased, okay, without tendency to overestimate or underestimate. So when we say estimate, it's the same as true value plus random error. Okay, so random error is very small, okay, in this case. So the idea is the reliability of the estimation will increase if the number of group size increase, right? Because eventually the random error with this plus and minus will be averaged out. So that's the basic idea of simple aggregation. Okay? So this is what you often use, isn't it? Okay, equal voting. Okay, equal voting. So the problem with this equal voting is crowd behavior. What is that? People tend to flock with the to follow the flock, okay? Like a duckling following the mother duck. Okay, so if the first person overestimate and announce first, the other will be influenced. Okay, so the reliability of that estimation, okay, actually does not increase much after 5 individuals. So that's the problem here of simple aggregation. Okay, whoever announced first will probably win, right? So this is an example of the technique. Okay, say I have 3 judges. Okay, name A, B, and C, and then I ask them, okay, you estimate this phone. How much is the price of this phone? Okay, and A said 3 million, B said 1 million, okay. C said 5 million. So then if you use simple aggregation, what you will get? You will get 3 plus 1 plus 5 divided by 3%, right? So then 3 million. Okay, so simple aggregation is just an average. Okay. Clear, yeah? Simple aggregation. Now we said, look, that is not fair. Why? Because some people are more expert than the others. So this is the basic assumption of weighted average. Okay. So some people are more expert than the others. So we should not use simple average. Okay. So a lot of voting, okay, for example, in Japan, okay, they create what is called a proportionate electoral system. Okay, they will give more weight to the underpopulated area in the rural district, okay, than in the city. So this is the Liberal Democratic Party (LDP). Okay, since 1950, always win until today, right? Never lost. So practically in Japan, there is only one party. Okay. So why? Because the farmer there get 5 votes. If you are family of farmer, you get 5 votes in Japan. Okay. If you are not family of farmer, you get 1 vote. So that's why they always win. Okay. So that's why the rice price in the price of the rice is very expensive in Japan. Okay. Because of this, like 6 to 10 times of Indonesia, the same price, the same rice, okay, very expensive. So that is the policy that they make so that they can win. Anyway, so this is an example, okay. We say, look, Judge A is 2 times more expert than Judge B. how we'll define 2 times is not important, but this is an agreement. So Judge C is 3 times more expert than Judge A. Okay? So then we'll say, okay, A is 2 of B, right? And then Judge C equal to 3A, right? So if you put this, what will happen? You put B equal 1. If B equal 1, you know that A equal 2. If A equal 2, then you know that C equals 6, correct? Okay, so you add all of this, the 3 of them become 9, right? Then the weight of Judge A is actually 2 over 9, right? So 22%, right? Judge B become 11%, Judge C become 67%. Okay, so 66.6. Okay, so then say the same number earlier. Okay, A is 3 million, B is 1 million estimate, and then C said okay 5 million. Okay, but the weight is different. Okay, now instead of how much earlier, 3 million. Okay, now become 4.11. There is a bias toward the one that has higher weight. Up to here, is it clear or not? Yeah. So this is judging toward certain attribute. Okay. If you want to talk about voting, we talk about it later. Huh? So this is first about factor and judging of certain attribute first. Okay, so this is called, there is a method, okay, that well known, this is very well known, that has been used widely since about 2,000 years ago, probably, or more than 2,000 years ago. So the Delphi method is an iterative group decision process. Okay, so Delphi is the name of city. Okay, where the panel of experts will give estimate on the weight or the value, okay, on their area of expertise. Right. So each person have opportunity to reevaluate his or her own decision, okay, after a feedback on the aggregation value. Okay, the judge does not know the estimation of other judges, so that they will not follow the crowd, right? So it's important not to follow the crowd in this group decision, right? Then the result, let's practice this. Huh? The result will usually converge after several rounds of feedback. Okay? If we practice, then we will understand what is the meaning of Delphi method. Okay? And then later on, when you have a team meeting, okay, instead of voting, let's do a Delphi method. You can say like that, right? So also in the company. So if you own a company or you are the leader in the company, so you probably want to do this group decision making. So this is very important things that you will do in your life, isn't it? Okay, let's do that. Okay, so let's practice. Okay, okay. Here, I have a coffee here. Okay, I have a coffee here. So let's try to evaluate the possible cost of this coffee. Okay, so Robusta coffee. So each of you will give your opinions in the class, should be in paper. So you chat me, okay, direct message. Okay, so Livy will tell me I'm the judge. I'm the facilitator. Okay, I'm the facilitator. Yeah, you are the judge. Okay, Joy, you direct message to me in chat. Livy, you direct message to me in chat. Okay, and then we will after that, after you direct message about how much is the price of this coffee. Okay, this is 200 grams of Robusta Lampung. Okay, just any opinion is fine. Okay, and then I will put it in Excel. Okay, so each of you will give your opinion. Okay, and then I will average and then calculate the standard deviation. So I will open Excel. Livy, tell me, is he still here? You chat me, Livy. How much? Livy said, okay. Okay. So I will calculate the average, okay? Average. I will not tell you the actual and standard deviation. So wait, average is average, and then standard deviation is STDP. Okay. So I will tell you the average, okay? First iteration is 77.5. Okay? 77.5 thousand. Okay? So 77.5 thousand this coffee. Okay, so second iteration, tell me what is your opinion about the price of this coffee? Okay, so I will type here second iteration. Iteration. Okay, go. Tell me now the chart based on the one that I just posted, which is 77.5 thousand. So you can revise your opinion or you can still insist, it's up to you. Okay, so how much? Livy, tell me your opinion. How much is that coffee? Chat direct message to me. Oh, okay. So I will copy this. Oh, okay. Now the last iteration, yeah, the third iteration. Okay, before the third iteration, I will tell you the average. Okay, the average is 65,000. The average is 65,000. Okay. So tell me third iteration. Right, iteration. Okay, tell me your opinion about this coffee. The average is now 65,000. So tell me, Livy, what do you think? Just type in chat, direct message to me. Livy, I just need to, okay, you insist, no problem. So 75. So now this is what I'm telling. Okay, now I will show the actual result. Okay, so this is your iteration 1, 2, and 3. Can you see it or not? Okay, this is amazing. This is Delphi method. Okay. Right? So this is Joy, this is Livy. So you see here, in the beginning, this is what you tell, and if you look at it, the average, it's going to be converged, right? And the most important, how do you know it's converged, is actual the standard deviation. Can you see it? The standard deviation will going down, become smaller. Okay, so this is amazing. Okay, this has been done not only in this class, so this is just simple practice. Okay, but if you look at this, this is what is amazing about Delphi technique. Okay? People tend to aggregate and influence each other. Okay, here you don't know the actual opinion of other person. Okay, what you get is only the aggregation. Why? If you know the actual opinion, that the bias become very big, isn't it? Right? So we want to avoid that. So that's why we have a Delphi method. Okay, what we give is only the aggregation, which is the average only. Yeah? Interesting or not? What? So tell me, what is your opinion about this? It's very simple technique. Yeah?
I was wondering, when will stop? When will we stop?
Usually when your standard deviation is below certain number,
Okay.
right? Of course, it's very boring if you ask until 10 times, right? Of the same thing. So usually two, 3 times is okay. It's converged already, right? So as long as you can see there is a, okay, what I'm thinking is to use the whiteboard. So something like this over time. Okay, so this is time. Okay, and this is the value. See, in the beginning you probably about this. Okay, and this is the data. The dot is the data. Okay, and you will see that the standard deviation is going down over time, over the iteration. Okay, that's the most important part. It's the pattern that is going down. It's converged. That is the most important part. Okay. If you do a Delphi method and actually becoming larger rather than lower, then probably you can see there is a person who is rebellious, or the person who actually create that chaotic behavior. Okay? Certain element that make that the system become not convergent. So you probably want to either remove that outlier, or you tell we need to create certain convergence here in the Delphi. Okay. Okay. Any question? Is this something useful for you or not? Team decision making, right? This is important. Okay. Next. Okay, so this is another technique. Okay. So now, instead of aggregating the final estimation, okay, now each individual will estimate the probability of each criterion. So you define the criterion and then you estimate, instead of the actual number, you estimate the probability. And then we take the simple average of individual probability on its attributes. This is an example. Okay, say you have two judges, A and B. Okay, so if we multiply its just probability, then we take average, we get 24%. Say you have two factors, okay, A and B. Right? So judge A will say, oh, probability is 20% will happen. Eh? This one, factor B will be 60%. And then if you multiply, okay, based on judge A alone, it's actually 12%, right? Judge B said factor A contribution is 40%. Factor B is more important, so 90%. So if you multiply, okay, you get 0.36. So if you average these two, becomes 0.24, right? So now, if we first average the individual probability, so this one is 0.2, 0.4, the average is 0.3, right? 0.6, 0.9, the average is 0.75, right? And then we multiply these two, we get 22.5. Okay, so instead of you multiply each of these, okay, instead of you multiply first and then you take the average, okay, you average first, then you multiply. That's the point here. Okay, so at least you know the result will not be the same. Okay, so based on this, you can say something that probably you can propose so that it will make you the winner. Okay. Because remember, social choice is a matter of aggregation function, right? Then what kind of aggregation function is you who propose? Okay, it's a matter of negotiation. Okay. Once you propose this, then it becomes binding to all members. Now, instead of value, okay, you can also decide based on the rank. So we aggregate the rank of the alternative. Okay, say we have charts of X, Y, and Z. Okay, will decide their preference on the three alternative projects named A, B, and C. So like a while ago, right? So which project should we select? Right? So a while ago I discussed Condorcet paradox. Remember? Yeah. So if you compare the two alternatives, okay, A is larger than B is larger than C, right? B is larger than C, but C is larger than A. So this is a contradiction. Yeah? It's violation of the transitivity inconsistency of the order of the rank. Right? So this is what happened if we use the rank. Instead of value, we use the rank. So then you have a inconsistency in the order. So then another proposal is something like this. This is called sequential alternative. So if the alternatives are not compared simultaneously, but in sequentially, okay, so the order of comparison will have the direct effect. Okay, say if the group will compare A to B first, right? Say if the group will compare A to B first, then we will eliminate the inferior alternative, and then we compare the superior alternative with the next alternative. Then A will win. Okay, so based on the sequence, okay, it will be chosen differently. The result will be different. Okay, so A compared to C, right? Then C will be chosen. Then if the group will compare B to C first, B will win. Then we compare to A will be chosen. Can you see that? Right? So the sequence matter. The way you compare, okay, the sequence matter. So this is very hard problem, isn't it? Because we don't know which one it is, right? So now if the group will compare A to C first, C will win. And then now comparing C to B, B will be chosen. So this is the order of preference ordering a while ago in this. Okay. So in the beginning, yeah, with A and B, the choice is C, right? With B and C, the choice is A. With A and C, the choice is B. So the group choice by majority is actually arbitrary. Okay. Such choice is irrational because it leads to inconsistency in the decision process. So this is an example what is called arrow paradox. Arrow is the name of a person. So basically this is Kenneth Arrow, Kenneth J. Arrow. Kenneth J. Arrow win a Nobel Prize winner for this paradox in economics. So based on decision-making, group decision-making process, okay, it is possible in the sequential alternative that you can cheat. Okay, and a clever member of the group would cheat by being dishonest about his own preference. Okay, if the preference of others already known. Okay, so in this case, the last person win. Okay? So, how to do that? Simply by delaying the decision and then listen first. Okay? The clever group member will win. So, let's take the example. Say, this is the actual decision that we have. Okay, Judge X will prefer C compared to A compared to B. Yeah? C is larger than A, larger than B. Judge Y will say, okay, actually this is his preference order. Okay, B is larger than C, larger than A. Right, and then Judge Z, this is the Judge C is supposed to be A larger than B larger than C. Right? This is in his mind only. Okay? Now, suppose A compared to B first. Okay? If you look at this, Z knows that if he uses his own preference, right? So, C will be chosen, yeah, because this is the least preferred project for Z. Okay? Remember, okay? This is the original preference order of Z. Okay? Now what happened is Z, knowing the judgment of X and Y, will lie. Okay, about his own preference. And then he said, no, what I want is actually B larger than A larger than C. So that what? So that what he wants, okay, will win. So this will make B win instead of C, right? So not A. And then in the first round, okay, B will win in the first round, and then B will defeat C in the second round. Right. So, can you see it or not? Leafy, Joy.
Yes.
So, this is how you lie about your own preference in order to win what you want. Okay, so because of the information. So information is important in this case, right? The information about the preference of other people.
But the winner is still B, right?
Oh, yeah, the winner in this case B, correct. But look at the preference of Z. A larger than B larger than C. Okay, so he does not like C to win. He likes A or B to win, right? So, okay, he cannot make A win, but he can make B win.
Okay.
Right? By lying about it, okay, he can make B win. Is A. Okay, so this is interesting phenomenon, and this is happening in certain election in the U.S. also. If you have several candidates, okay, and they are telling, okay, don't vote for this one, you vote for that, the other. So, and then suddenly the third person win rather than the second person. Okay, so that's what happened. Okay, so Kenneth Arrow win a Nobel Prize because of this, what is called Arrow impossibility theorem. So if you want, I have the book about this, okay? I have several books actually. Okay, if you want, you can read the detail, okay? So in here, I just put 2 or 3 slides, but the detail is so thick. Yeah. Arrow asks, this is very important, that's why this is creating a framework of all social choice. Okay? Whatever your aggregation function is, okay? Arrow impossibility theorem exists. That's why this is important. Okay? Arrow asks whether there is a satisfactory method to determine the group preference when the preference of individual count. Okay? So remember, group and individual. So Arrow asks whether there is a satisfactory method to determine the group preference when the preference of individual members are expressed in the ordering, in the ranking. Okay? And then he come out with 4 conditions that satisfactory procedure should meet. Okay? So, remember, this is utility. So, it's based on ranking, okay? Order of preference, not based on the intensity. Not a while ago we used the value, right? The intensity of the preference. So, no, this is based on the order. Okay? Just utility theory. So, we have discussed about utility theory last meeting, correct? Okay, so what is the condition? So, the method, the aggregation function, okay, should produce transitive group ordering. Okay, so I call this U. U mean unrestricted scope. That means sometimes they call it collective rationality. So basically transitive. Consistent means transitive. If A is larger than B and B is larger than C, then A must be larger than C. Transitive. Okay? That is the first condition. Logical, right? When we say rational, that means transitive. The second is P. P means Pareto. Pareto means consensus. Okay? So if every member in the group prefer one option over another, so must the group, correct? If everyone in the group prefer X compared to Y, then the group must also prefer X compared to Y, right? So this is called Pareto. So Pareto principle. When every individual prefer X to Y, then the aggregation function would rank X above Y in the social order. Okay, so this is the second condition. The third condition is I in here. The group choice between 2 alternatives, say A and B, depends only on the preference members between these 2 alternatives and not preference of any other options, so that the individual cannot cheat. Okay, so we call this independent of irrelevant alternative. Yeah? Independent of irrelevant alternative. So you cannot say, oh, I have 2 choices. Okay, these are the 2 alternatives. After doing this, after you do voting, oh, I created a new alternative C. It's not allowed. right? So when you, in the beginning, you have only three alternatives, then you vote for the three alternatives. You don't create or remove this alternative. That's the meaning of independent of irrelevant alternative. Okay? The last condition is no dictatorship. No individual can impose his or her preference to the group. Right? So the aggregation function cannot take only based on one individual preference. Okay. Dictator means he or she always win, right? Right. So the group will always lose. So that is not allowed. Okay. Now, what is called arrow impossibility theorem is this. So arrow proof mathematically, okay, it said that no aggregation function can guarantee satisfy all four conditions above. What's the meaning? Okay, so it is impossible to create a democratic system, okay, for resolving a difference of opinion. Okay, that's the interpretation. Okay, so to make it in detail, okay, if you have an aggregation function that is transitive and Pareto, okay, and non-dictatorship, democratic, right? Okay, then it must be, it must not be independent of relevant alternative. 3 is okay, but 4 is not. Okay, if you have a condition, an aggregation function that is Pareto principle, yes, non-dictatorship, yes, independent irrelevant alternative, yes, it must be inconsistent, like the Condor's paradox here a while ago. Yeah, this one, inconsistent. This is one of the example of arrow impossibility theorem. Right. So 3 condition is allowed, but 4 condition is impossible. You get it or not? Oh, up to here, is there any question? So arrow 4 condition and the theorem that impossible to satisfy all is the foundation, yeah, the framework. Now, this is another technique which is non-Pareto. Okay? So it is example of unrestricted, okay, non-dictator and independent irrelevant alternative, but non-Pareto. So this is number 4. This is simple, robust, and practical. Okay, what to do? In this case, okay, in this technique, individual will vote for all alternatives. Okay, you can vote for all alternatives that you consider at least acceptable. So you don't vote one for one, right? You one for many. This one, yeah. So you vote for all alternative, and then of course the group decision will be you find the alternative that receive the most vote. Okay, so this is non-Pareto. Okay? You ignore the information about the individual preference. Okay? The actual ranking in the individual is not shown here. But this is also avoid the paradoxical result like the Condorcet paradox above, because we don't tell the individual preference. Oh, up to here, is there any question? Okay. If not, we go to politics. Huh? Okay. So a vote, definition first. Yeah? A vote is a formal expression of opinion or will, okay, in response to a proposed decision. So when we say voting, that means to cast or to conduct a vote. Okay. Simply, how to simply vote in the meeting? You just raise your hand. Okay. So an election is a formal or organized choice by vote of a person for a political office or other position, or probably some factor. Okay. And a coalition, this is important. A coalition is an alliance of combined action. So basically, coalition is a cooperation. Okay. For example, several parties create a coalition, an alliance to form a government. Right? So, that's the definition. When I was student in the third year in Petra also, okay, I was sent by Petra to Jakarta to join the National Forum for Engineering Students at the time. Yeah? So they have vote. They said based on Pancasila, we don't want to have voting, so we only want to have consensus. Okay, so then they try to create consensus about the meeting procedure, tata tertib rapat. Okay? So the meeting procedure, okay, which supposed to be, they already draft it, so we only need to vote. If you vote it, probably 5 minutes is finished, right? Okay, this is the procedure for the meeting. Okay, and the conference was 3 days, 3 nights, and I was expecting that procedure of the meeting will be read by half hour, and then we vote and then finish, isn't it? And then we go to the real meeting, isn't it? Right? But what happened is they disagree with this meeting procedure, okay? And then they discuss it until midnight, and then until 3 o'clock in the night, and then they postpone it, and then start again 7 o'clock in the morning for the second days, and then again they meet until the third day, just talking about tata tertib rapat, which is the meeting procedure, and then the conference was finished just to discuss the tata tertib rapat. That's super stupid way to a democratic way of musyawarah mufakat, right? Okay. So when you don't want to vote and you deal with consensus, that is the most stupid and inefficient way. Okay? And that still happen in Indonesia. So that's why I'm telling this lesson about group decision making is important. Don't try to reach consensus. Just do a voting. Okay? By voting, all these 5 minutes, just raising hand, finish, just count, right? Rather than trying to create the consensus. And you can also do what is called coalition. So you do a negotiation behind the table, and then you know what is the vote, right? Then you can make a deliberation for that. Okay. Okay. So I will discuss a little bit about what is several type of voting. Okay. So we have what is called plurality voting, cumulative voting, runoff voting, negative voting, approval voting, and so on. So these are a few type of voting that we can discuss, just the definition. Okay, and from there we will go to the actual things, which is the non-cooperative, the cooperative game. Yeah. Okay, so what is plurality voting? Plurality voting, in plurality voting, this is what you usually use, right? So each voter, you, will cast one vote or no vote for a given candidate. Yeah? Okay. So now the candidate with the largest vote, the total, the largest total vote are declared elected. So now suppose, example, you have 8,000 voter and you have 5 candidates. Okay. Election, this is talking about election. Okay. You have 8,000 voter and then 5 candidates. Okay. And now you are a party, right? So you want to form a coalition, right? Okay. So then you check the other party, how many votes that they have, right? So coalition of 4,001, that is half and 50% plus 1, right? Majority. Okay. So 4,001 members can elect candidate of its choice because it's majority win, right? This is plurality voting. Okay. So if you create that coalition, okay, and then most of other candidates will only receive 3,999 votes. Okay, so your job in this kind of election, okay, to make a coalition so that you can get the majority. Okay, this is if you base the voting based on plurality. Okay, each voter casts 1 vote and then or no vote, okay, and then the largest vote win. Okay, the second technique of voting is just the same as earlier I mentioned, approval rating, the same as this one. Okay, so this is called cumulative voting. In cumulative voting, okay, each voter will cast a total of E vote. Okay, so E is the same as the total number of candidates. And then you will distribute this E, not necessarily in integer, among as many candidates as desired. Okay. Why you learn this? Suppose you are in a company, you can create this cumulative voting, isn't it? As a member of board, you can create this, and then you know how about how to win based on this cumulative voting. Right? So it's up to you to create the technique of aggregation. Okay, so the candidate with the most vote declare winner. So I will give example. Okay, there are 4 voters, for example. Okay, this is the board member of a company A, B, C, D. Okay, each voter, okay, can cast, for example, 5 votes, okay, to the elected candidate, 3 candidates, X, Y, and Z. Okay, so the voter B, for example, will give 3 votes for X, 1.5 vote for Y, and then 0.5 vote to Z. Okay, so the total is 3 plus 1.5 plus 0.5, that is 5 votes, right? Similarly, voter D, for example, will not use all his vote. Okay, he can use only, I give 4 votes to Z only, and so on. So this is the example that you can cast vote, okay, of the maximum vote that you want. Is this clear or not? Now, usually the maximum vote, the total number of votes, is the same as the total number of candidates. So this is, in this example, is not the same. So, but usually will be the same. Okay. So now, if the total vote is the same as the total candidate, we can have a mathematics. Okay. So here, V in here is the total number of voters. Okay. N capital is the total number of votes to be cast. Right? Small n here is the total number of voters in a coalition. Voter in a coalition. So E is the total number of candidates to be elected. Okay? So then, under cumulative voting, so if you use the rule of cumulative voting, so then you want to create a coalition, right? Coalition means kerjasama. So you cooperate among n voter to guarantee that you will win certain number of candidates. Y. Okay? So the number of candidates Y is the same as the floor function. This is the floor function. Floor means the largest integer that less than that number. Okay, so of n multiplied by E divided by V, small n here. Okay? So if you want to create a coalition to make a winning candidate, okay, you probably want to use this formula in a cumulative voting setting. Okay, let me give an example. So, suppose the total number of voters is 81. Okay, and the total number of candidates to be elected is 8. Right? And then you create a coalition of 46 voters. Okay. The question is, how many candidates can this coalition elect? Right? So based on that theorem a while ago, okay, so under cumulative voting, a coalition of n voter can guarantee the election of Y candidate. Okay, so we use this formula. That coalition can elect, okay, this formula, n times E, n is 46, right? E is 8 divided by the total number of voters, which is 81. Okay, so the coalition can elect 4 candidates. Okay, so yes, yeah. By giving each of its 4 candidates, how many votes? 92 votes. Okay, so equal vote, 92 votes. Okay, let's make a cooperation so that you will win. So I will select this 4. Okay, how much vote I will give. So you know how to distribute. This is politics, right? So actually, if you want, okay, if the voting is not necessarily discrete, not necessarily integer, you can actually elect 5 candidates by giving each of them 73.6 votes. Interesting, huh? So this is how you will make a cooperation, okay, to create an alliance so that you will win in the voting. Okay, so you can start to create a political party if you want. Okay, based on that. Okay, so this is happened in Indonesia. Is it correct? I don't know. Or in the Philippines. I forgot. So vote with one candidate as a plurality voting, the same as plurality voting. Okay, but there is a second round. Okay, if the top 2 vote getter, okay, did not receive majority. Okay, so there is a second election. Okay, if you cannot, so the first election is plurality voting. Remember plurality voting 1 to 1, right? A while ago. Okay, 1 to 1. Okay, and then but if you cannot get the majority vote, remember when I said majority mean 50% plus 1. Right? So if you cannot winning the majority vote, then again, among these 2 winner only, will have the second round. Okay, so this is called runoff voting. Okay, so election can be sequential, not just one time. Okay? The point is that. Next, okay, Oh, this is nice for the company or maybe for the team group. So you can propose, okay, each voter can cast either a vote for the candidate. So that a vote for mean positive, right? Or a vote against the candidate. So in that case, you will put negative on the ballot. Okay. So the rule is the voter cannot vote for or against more than one candidate. Okay. So unlike the cumulative voting, okay, this is similar to plurality 1-to-1. But in plurality 1 and 0, right? In here is positive and negative 1. Is it clear or not? Okay, so the candidate with the highest net vote, okay, the highest positive or the lowest negative will win. So the good point in here is you don't need to have a runoff, yeah, second election. Okay. Even if no candidate with net vote positive, okay, so even if it is negative value, they will still win. Is this nice? Clear? Last but not least is the approval voting. Okay. What is this? Vote for one or more candidate. Okay. A voter can cast a single positive, only positive, for as many candidates as he wishes. So, voter can vote, the voter can vote between one up to the total number of candidates. Okay. And there is no runoff election. So, instead of 1-to-1, you can 1-to-many. Okay. Say you have 8 candidates, you can select one of them, or 2 of them, or 3 of them, up to 8. Okay. So these are all the technique that you can use for voting. There are probably many others technique for voting, but these are the most important one. Okay, up to here. Any question about voting, election, coalition? This will give you the background, at least. You understand what is plurality voting, you understand what is cumulative voting. Okay, so the last part here is the most important. This is like the introduction to game theory. Okay, so today we'll discuss game theory after lunch. Okay. This is called n-person cooperative games. Yeah? So similar to voting situation. Okay, but at this point we call this, instead of we call this voter, we call this player. So this is a game, okay, based on weighted majority games. So what is this? So there's a quota Q, and then there is a weight for each player, for each voter, the player I. So then your job is to create a coalition, right? Cooperation, right? Your job is to create a coalition C so that you will win. Okay? Whenever, okay, the total weight, okay, of I element of C, okay, is larger than Q. So the Q is the threshold. Okay? So the game will be expressed as very simple game like this. Q semicolon W1, W2, W3 and so on until Wn. N is the number of players. Okay, so this is the number of players. So this is the assumption that the Q must be larger than the total weight, right? So because it's a majority game, so it must be 50%, above 50%. Yeah? Q must be larger than, not equal, yeah? Larger than. Okay, so in business application, the percentage of the company stock, right, of that an investor own can serve as the weight in the weighted majority game, isn't it? So if you own certain number of stock, okay, share in the company, then you as individual or your coalition, a group of people, okay, that own over 50% of the stock will have full control. Basically, you have a 100% voting power, okay, whenever the decision is made by simple majority vote. Okay, so a group with 50% or more share of the stock can veto, can block any of the action in the company. So you also be careful, okay, when you create a startup later. Okay, so check about the control of your share there. Okay, the well-known example is Steve Jobs, that in Apple he was kicked out for the company that he started up, right? Okay, so let's talk about equal power in this simple majority game. Okay, so if you have n player and each of these player have equal weight, okay, 1, 1, 1, 1, 1, and then there is a Q here as the threshold, then we said each player have equal power. Okay, so they have equal power if 1, 1, 1, 1. Next, let's check this. Say the threshold is 51. Okay. If you add 28 plus 24, how much? +28, 24, how much? Unmute.
52.
52, so larger than 51, right? How about this one? 24 plus 24. Only 48. It is less than 51. So that means this first player, player 1, is stronger than the last 3 player. Why? Because this player, number 1, okay, need only one other member to pass an issue, right? But if the 3 join a coalition, then player 1 will lose. Okay? If only 2 join a coalition, okay, and then still cannot win. Can you see that or not? If 2 players with 24 weight, okay, join a coalition, the threshold is 51, so still cannot win. They need to have 3 to win the vote. Do you understand or not this one? Biffy, do you understand the meaning of 51 in here?
Yeah.
Okay, so this is the weight of each player, okay, and then your technique is to create the coalition. Okay, the total of that coalition must be larger than 51. That Q is 51. Okay, so you know that player 1 in here is stronger player because he or she need only 1 more player, okay, while the others need more than 2. Okay, how about this? Okay, 26 plus 26, how much?
52.
52, larger than 51, right? So that means if the two make a coalition, will win already. How about this one? 26 plus 22. 48, right? It's less than 51. So that means player 4 is the powerless here. Okay? Because any winning coalition containing her, okay, will just win without her. Correct? From this voting weight, you start to realize your power. Okay. This is what is called veto power. Okay, I need to veto power. A player or a coalition, it's said to have a veto power. Okay, veto power. Okay, if no coalition is able to win the ballot without his or their his or her, okay, or their consent. Okay, for example here, look at this. The threshold is 51. Okay. Now player 1 have 50, player 2 have 49, player 3 have 1 vote. Okay. So clearly player 1 have veto power, isn't it? Why? Because if you add the two of them, 49 plus 1 is still 50. It's less than 51. Right. So in that case, they cannot win. Okay. How about this? Okay, the threshold is 3. Okay. And then 1, 1, and 2 is the weight. Okay. So clearly player 3 have veto power. Why? Because okay, you cannot win that election without that player. Okay. So that's the meaning of veto. Okay. So in the UN, okay, this is the famous example, right? In the UN, United Nations Security Council, this is the rule. Okay, you can check in the UN. Okay, there are 5 permanent members with veto power. Okay, and there are 10 non-permanent members that are replaceable. Okay, that can be represented as weighted majority game. So what is the value of the game? Okay, here, the threshold is 39, right? And then each of the 5 permanent members have 7. Okay, and then all the others non-permanent members have 1 vote. Okay, in order to win, you can check if the 10 non-permanent member, for example, the 10 permanent member said agree, okay, it's just 10, less than 39. Okay, so they need a 39 vote in order to pass a resolution, right? So that's the meaning of veto power. So you need the consent of that in order to pass the action. Veto power is different from dictatorship. Okay, so the next one is dictator. What is this dictator? A voter J is a dictator if he, okay, or she control any vote by himself. Okay? How do you see? The weight of J is larger than or equal to Q. Okay? So there can only one dictator in this game. Okay? And all other players are called dummy. What is dummy? Dummy are the player who has no real voting power. Okay, I give you example. The Q is 3, the threshold. Okay, and then this other the weight. You see, 1, 3, and 1. Player 2 is a dictator. Okay, you will see, if you said democracy is voting, is that correct? What's the difference between dictatorship and democracy? Now you start to realize, okay, voting does not mean democracy, isn't it? Okay, in voting you can still get the dictatorship, no? How? Simply by putting your weight equal or larger than the threshold. Surprise, surprise, surprise. Right? So many people don't understand this, right? Then they think, oh, you are voting, you have election, then you are democracy. It's not. Right? It's actually dictatorship. Okay, so these are the next one. Based on the power, okay? The following games, these 4 games, okay, they are similar in terms of power. Similar in terms of power. Why? Because they are the same. Okay? Because they give rise to the same collection of winning coalition. Okay? So if you want to win, right? You see, if you want to win, this is the threshold is 3, right? If you want to win, you must create this. This one, right? This must join in order to win, okay? Or okay, this must join in order to win. Okay? And the 3 of them must join in order to win. Now, identical, okay, in terms of voting influence, these 2 games are actually identical, again because they have the same coalition in winning both cases. Yeah? So you need to join, okay, either this one or the 3 of them, right? So the combination are the same. The combination of players are the same. So this is called identical games. So, okay, tell me, okay, this is the last slide. So tell me, what did you learn today? Is this interesting for you or not? I don't know. Is this useful or not?
It's definitely useful because actually we can actually manipulate
Correct.
certain things to gain our favorable outcome. Like
Correct.
we can disclose something and like lie, cheat,
Hmm.
and like make even like how important is like the
Coalition.
Yeah.
Yeah, alliance, right? The coalition. So,
But then it's actually there's a lot of to think about to like actually have our favorable outcome
correct.
because it's not quite that simple, right? Yeah.
It's not simple, and I told you in the beginning that this is just a scratch of the surface, okay, and still very deep behind this. Okay, I myself still learning about a lot of things that I still don't know many things about this. Okay, but this is a really interesting topic, okay, and very active research. Okay, and basically the whole world is researching about this also, right? Because this is also very important. When we say democracy, when we say dictatorship, suddenly you start to realize something. Hey, even in voting, you still have dictatorship. Okay? Okay. Then suddenly you realize, oh, it's not always voting mean democracy. Okay? And again, the application is not only in politics, can also be in business, in organization, okay, in the group, and so on. So I also created research about my own group decision theory, okay, and I applied this in several occasions, but I think it is not yet done. Okay, so in the next hour, we will discuss about game theory. Before that, maybe we have only a few minutes before lunch. So uh, the content of the midterm is until group decision. Okay, the game theory is not included. The conflict, the next game theory, the game theory of the and cooperative game is included, but the next one, okay, the next hour is not included. So from the beginning until today. If you still have any question about those material, please tell me. As usual, the exam is in Lentera. That is Moodle exam, right? And multiple choice, as the usual my exam. Uh, Positive minus negative.
Sir, for the next half of the semester, can we not use Lantera, like change platform? Because in Lantera, we don't get any notifications when you post something, or like, yeah, we don't get anything. That's why sometimes I forgot to submit my homework, or I forgot to read before class, because I actually don't get any notifications. So I completely forgot about it. Then I'm like, oh no, we actually have something like
Oh
that. We
no,
have no
I don't know
notifications
that.
at all. Yeah.
Oh, I will
So
ask is the notification is the problem?
yeah, it just doesn't like give us notification. They only give us notifications when we submit something, and that's it. Like, oh, your submission is complete. But then like when you post something, or like when you update an information, post an announcement, we don't get anything on the email. So it's like we gotta like independently check all the time. And sometimes we just like miss it, right? Because there's like several class, and like we miss a lot of things sometimes because of the no notifications thing.
Okay, I did not know that. How about the Moodle last time? Do they give notification to you?
Before Cloud Lantera, I believe so. Every time someone posts an announcement, we will get something.
In Moodle? No, right?
Previous one, Lantera, not the Cloud Lantera thing. And
Oh, in
in
my
your
Moodle, I
Moodle,
don't
you also
think.
get.
In my Moodle, did it give you to.
I think so. I received
Really?
emails. I think I
You receive
forgot.
email from my Moodle?
On the last class, I think so.
Oh, really? But
But
no.
for this one, we don't get anything. That's why I'm a bit like, oh no, we have
Okay.
an assignment or no, like that.
Okay. So I will ask first the administrator of Lentera, okay, if they can actually change that setting.
Okay.
Okay. So if not, then yes, we can uh, tell you something about it.
Okay. Thank you, sir.
Okay. Thank you. Uh, you want to break now or you want to continue with the next topic?
Can we break now? Just
Okay,
like 10
let's
minutes.
break
Yeah.
now. Okay, let's come back
Okay.
at 1 o'clock then.
Okay. See you, sir.
Right. So good afternoon again. Uh, we have a group decision. So this material that we discussed today. Now is actually supposed to be after the midterm. So but we are a little bit advanced. So it's an introduction to game theory. Okay, and if you look at in Lentera, you can see we have several slides here. Okay, so probably in 2 or 3 times we can finish all of this. Okay, so before May, you probably can already done with this game theory, and then we can discuss more on game theory. Okay, so what is game theory? So today we'll discuss the very introduction. What is game theory? Okay. You can basically I can read this slide, but I hope you can make it more livelier than just reading the slide. Okay. By your question, of course. So, can you see the slide? Okay. So, in this lesson we define. Okay, this is just a very introduction. So, I don't talk about computation at all at this point. Yeah? I'm just talking about what is game theory, what is the objective, what is the assumption, what is the classification, something like that. Okay, so this is like the last part of decision analysis, right? So we have discussed about decision under certainty, uncertainty, risk, utility, and group decision making. Now we talk about decision under conflict. Okay. So, what is game theory? So, game theory is basically a study, okay, how smart and ruthless people should act and interact in strategic setting. Okay. This is not wrong. Huh? I'm telling this is ruthless, meaning okay, not necessarily good things. Okay, so in game theory, we do a systematic study about strategic interaction among rational individuals. So the assumption here is rational, right? They have conflicting or cooperating interests. So everyone have interests, right? So now game theory is concerned with the action of the decision maker, okay, who are consciously about their action will affect other people. Okay. Now, when we say strategic interaction, okay, we mean that the individual know, okay, their own action will have effect, right, on the outcome and still act accordingly. So remember, the assumption here is important. Okay, in game theory, you know the consequence. You know all the alternative. Okay, that's the most important part there. You know all the alternative. You also know the consequence, and you still act accordingly. Okay, and this is interesting. Why? Because now you start to see. Okay, in previous decision analysis, we are talking about you yourself against nature, right? Or maybe you are lucky or unlucky, something like that. But in here, you are against other people, or company against other company, nation against other nation. So the assumption is self-interest, selfish. That's the basic assumption here. Okay, so there are two kind of games. Yeah? One is a cooperative game. The other one is competitive game. So you can separate game theory into two big parts. One is cooperative game. The other one is competitive. Okay? In cooperative game, you can have two possible choice. One is without conflict. The other one is with conflict. What is cooperative game? Okay. Cooperative game, like a while ago that we discussed this morning, right? It's a game which the player can make a binding commitment. Okay, so Non-cooperative game is called competitive game. In here, you cannot make a binding commitment. That's the difference. Like you create a coalition, that means a binding commitment, isn't it? Right? So now, when we say cooperative game, does not mean no conflict. Okay, there is two possibility also. One is a cooperative game without conflict or with conflict. These are the example I gave you. So member of workforce choose which of equally difficult tasks, for example, to undertake, and then they best coordinate to each other. So it's a teamwork, right? In a team, you work together in a cooperative way without conflict. That is one of the game theory setting. The other one is a cooperative game with conflict. For example, you start to bargain, okay, between buyer and seller. They are cooperative, but there is a conflict of interest, right? One want to go higher, the other one want to go lower, right? So then you bargain for the price and the quality and so on. So they are still cooperative game. Okay. The second is no binding agreement. So this is called non-cooperative game or competitive game. Okay. The other word is called strategic game. Okay. So you remember when we said strategic game, that means competitive, non-cooperative. Again, in non-cooperative, you also have two possible categories. One is with conflict and the other one is without conflict. Okay. So one example of non-cooperative game with conflict is prisoner dilemma. The one in the right side here, you can see there are two prisoners, right? And they have two choices, whether they confess or they deny the involvement in the crime. Okay? And if both deny the involvement, both will get 3 years. Right? If one deny, the other one confess, okay? So of course the one who confess will get 5 years, and then who deny will get 0 year. Right? Now if both confess, okay, both will get 2 years. Okay, so that is non-cooperative game with conflict. Okay, so two parties, the two prisoners. Now, another possibility is non-cooperative game without conflict. So, I've been involved in, for example, software development company, okay, say for pedestrian simulation. Okay. And these companies, okay, several companies, we are actually competing, right, to each other, okay. But because we are competing to each other, we also create a standard, okay. We also create a standard agreement among these companies so that our product can talk to each other. Okay, our software can be linked to other software. By doing so, we actually create a higher market, for example, yeah? Higher market share. So by doing so also, we actually reduce the new player competitor. So those who actually create the industry standard is the one who win the competition. Okay, so that's why they pay a lot of attention to this industry standard. So this is example of non-cooperative game without conflict. Okay, so let's focus. Most of our focus in this lesson in game theory is about strategic game. What is that again? Strategic game. Strategic game is non-cooperative game with conflict. So most of our situation is here. So you have 2 or more players, okay, and then there are some choice of action or behavior, and you have outcomes. Okay? And then, now, the final outcomes will depend on the strategy chosen by all players, not just you. Because it's kind of group decision, right? So the result will become a kind of group decision, but this is with conflict. Okay? So the individual decision, you as one of the player, will have impact on the other player. Okay? So what we don't include here, we don't include game of pure chance, for example, lottery. Okay? And we don't also include game without strategic interaction between players. So, for example, solitaire, for example, we don't include here. Okay? So what is the goal? The goal of game theory is to organize our knowledge, okay, increase our understanding about outside world. Okay? You want to predict the actual outcome. So there is a prediction power. So to achieve this goal, okay, of course, we need to create rules, right? We need to postulate, okay, what we can do and what is the assumption and so on. Okay, so each individual will act or behave under certain assumption, which is rational, for example, right? And then what is their objective, what rule of the games, we already set. Okay? With that setting, then we can predict. Without that setting, there is no way to predict. Okay? In prediction, there is always invariant. So that is the one that we say. Okay, what is the assumption? The assumption is no mercy, no compassion. Okay? This is not religion. Okay? So some people will ask why I teach this in Petra Christian University. Okay, anyway, but this is science. Okay, this is purely mathematics. So the theory exists based on the assumption that no mercy, no compassion is only self-interest. So, and this is the reality, right? In reality, most people care solely about themselves, and everyone knows and accepts this, actually. We don't deny this as fact. This is important. Okay? Otherwise, they will tell you about mercy, compassion, and then no self-interest, socially acceptable. But once you don't know about game theory, then you are under other person's influence. So game theory is very important in this case. Okay? Now, what is the implication of self-interest? Example, okay? So employer would like, say the worker will say, oh, give me a raise, right, in my salary. Okay? Why? Because it's nice thing to do. Nice thing to do. It will not happen. Okay? So employer will never give you a raise because it will be nice thing to do. That is not self-interest. Okay? It's not about mercy, it's not about compassion. About self-interest, then you will get a raise only if you can convince your employer that it actually serves his interest to give you more money. Wow. Right? So, you're talking about minimum wages, for example. Yeah? Oh, then the employer will say, if you got minimum skill, minimum education, and show minimum motivation, okay, and provide minimum contribution to the workplace, why should someone be forced to pay more to you? Right? So it's not in between the self-interest of the employer to give you the raise. Then they will ask the government, okay, government, you have the force, power, so force the employer to do so, right? So that is and it is within the self-interest of the government to do so. Right? So then you can see there are several self-interest people that interact with each other. And this is interesting. Okay. So now, in this class, I will tell you frankly, okay, beware. If you end up enjoying this lesson, it's not because I teach it for the purpose of making you happy. Okay? So I teach it to maximize my own payoff. Okay? I don't care in any way about your welfare. You should remember that. Okay? Okay. So, an individual is rational. Okay? So, if she or he is well defined, has well defined objective or preference, right? Over a set of possible outcomes. So you have several alternatives, then you know which one is higher than the others. You already set your own preference, okay? And you will implement the best available strategy that you can do, right? Remember, this is the basic assumption. You have alternative and you know your own preference. What you want, you know. Okay? So if you don't know what you want, then this is not in game theory. Okay? Because you are not rational anymore. Okay? If you are not knowing what you want, you are not rational. That's the basic assumption here. Okay, so individual knows the strategy available to each individual. Okay, and you have complete information, consistent preference, okay, over all the possible outcomes, and you are aware of those preferences. Not only you, as one of the players, aware of all of this, but also your opponent should be equally rational. Okay? Only then we can determine the best strategy. So, example, okay? If one of your opponent, if your opponent is actually crazy, irrational, right, then you cannot use game theory. Okay? Clear? Okay? This is the most important assumption there. Okay? If they are not rational, then this theory of game, okay, cannot be used. So, important here is it's not enough that I know about my own action and consequence, okay, but I also know about yours, right? And what will affect the outcome. But I must also know that you know this fact. You got it or not? Two players both must know the same information. Okay? So this is the basic assumption of game theory. If you have different information, then totally we cannot calculate. Okay? So this is the basic assumption that we need. Example here. Okay? So in my example, I always use table. So in that case, I will say row and column. Okay? Instead of giving a name, I just name it row and column. So say row nation will have, in this example, will have three alternative choice. R1, R2, R3. Column nation will have three possible alternatives, C1, C2, C3. Okay, and these are the outcome. See, that means if row nation choose R1 and column nation choose C1, okay, then this fail means the payoff for the row nation. Okay, so fail for the row nation mean success for the column nation. Can you get it or not? So remember that when we get this table, you should know that this table is always for the row. That means the opposite is for the column. Okay, that's how we throw. Otherwise, you will throw two tables, one for the row, one for the column, or in one table you will put a comma, right? One for the row, one for the column. That's also okay. But if we don't put like that, that means all for the row. Okay. So in this case, we ask, okay, which strategy is the best for the row nation? Which strategy is the best for the column nation? Okay, so similar to decision under risk, under uncertainty, right? So you have a table, okay, very similar, okay. So and you have certain payoff here, so very similar. Okay. The only difference is in decision under uncertainty, you are against nature. Now you are against other player. But this is generalization, mean the other player can be nature. Right? It's not necessarily human. Okay, the other player. Okay, so say each nation does not know what the other nation strategy that will be selected. Right? You don't know that there are several choices. Okay. But you don't know which will they will choose. Okay? But we know all possible strategies. Okay? And it's payoff. So this is the basic assumption of game theory is perfect information at this point. Okay? And complete plan. Okay? So in this course, I will just talking about this, meaning the game with perfect information. Okay? Over years, okay, Harsanyi, for example, you can type in Google. Harsanyi get the Nobel Prize on game theory of imperfect information. Oh, that's deeper, okay? So I don't discuss in this class, but at least you know there is game theory with imperfect information. Okay, so we also assume that the opponent also knows all the possible strategies and each of the payoff of ours. So we have the same information. Yeah? Then you ask, why? Why should I learn game theory? This is the introduction, so I need to give motivation, right? So by learning game theory, you will learn that even when everyone actually act totally ruthless, right? Extremely competitive, okay? The logic of game theory often dictates that, hey, look, even in the competitive situation, selfish people cooperate. This is interesting, right? Okay. They cooperate because it is within their self-interest. Okay. And then they even treat each other with loyalty and respect because within their self-interest to do so. Okay? What is the lesson? Then you can actually create, if you want to control, right? Okay? In game theory, of course, one is to understand the game. Yeah? The second is to predict, right? This is what we learn in our class. Okay? But if you want to control, that means you will change the input, the input of the payoff, so that you can control the outcomes that you want. Okay? We don't learn that, but at least you know there exists on that. So you will learn based on your move, okay, what you think other people might do. So based on game theory, even though you are having self-interest, you will care about others. Why? Because if your move is based on what your opponent might do, and their move is based on what they think you are going to do, then your move will be in fact somewhat based on what you think your opponent think you will do, isn't it? So this is careful. Huh? So it's not just about the actual outcome, but you start to think what others will think about you. That is the actual lesson of game theory. So I give in the beginning here so that you will know the philosophy behind. Okay? Love happened because there is self-interest, you know. This is important there. It's not just because, oh, I do it out of morality and so on. So there is no self-interest, not like that. Okay, in game, based on the lesson of game theory, you start to think of others because of your own self-interest. Interesting, right? Okay, now let's talk about the component. So there are 4 components of any game. This is like the framework, okay? Of any games, you will have a set of players, right? And each player will have some action, and there is some payoff, and there is some information. Okay, I will discuss a little bit about information later. So what is player? Okay, players are individuals who make decisions, right? So again, I need to emphasize that we assume rational player. Okay, so each player will maximize his or her utility by the choice of action. Okay? The payoff in game theory is utility. Okay? You can convert it to money, is up to you, but this is utility. You remember utility we discussed last meeting, right? You even compute your own value, right? So each player always assume that other player also trying to maximize their payoff. So that is the rational player. Nature can also be another player. So it's a pseudo player who take random action at specific point of the game. Okay. Oh, okay. This is an example. Okay. So this is game against nature actually, right? So say you are an oil company, okay? So this is the payoff. If you drill, okay, if you drill and you have no oil, okay, you will lose 7 million US dollar. Okay? If you drill and you get oil, you will get 10 million US dollar in profit. Okay? If you sell equipment, instead of drilling, you sell your equipment, you will earn 1 million. Right? Drilling equipment is expensive, right? So, and if you sell equipment and actually there is oil, okay, you lost opportunity $5 million. So the question is, again, which strategy is the best? Okay? At this point, I don't talk about how to compute yet. Okay, we just give the example. This is just to whet your appetite. So the number of players can be 1 person a while ago, right? Can be 2 person and can be n, coalition of n players. So the second component is action. Okay, action is the move. Okay, so each player will move without knowing what other person is going to do. Okay, so it can be a combination of action, right? So the most important here is this. The action can be simultaneously or sequential, right? Now, sequential means I will do first and then you next. Or you first and then I'm next. That's sequential. Or simultaneously, meaning at the same time, okay, you take the same action and then we see the result. Okay, so if you don't know and we don't specify, okay, in our class, then we assume they will move simultaneously. Okay, if I don't telling anything, okay, that means there is no sequence. They must do simultaneously at the same time. Okay. What's the difference between action and strategy? Okay. If you have only one game, you have several actions like alternative, right? So, but if you have many sequential games, okay, then you start to create what is called strategy. Okay? So the plan of action that maximize the payoff depending on the information. So it's a set of action. Okay, that is called strategy. So in a simple game, it's only one game, then action is the same as strategy. If you have many games, then you have what is called strategy. Okay. Next is the payoff. The third component is the payoff, right? What is that? Well, payoff is basically consequence, right? Consequence of the, for each player, what is the consequence if for each alternative, yeah? Or for each action. So that payoff can be material reward, for example, money, or simply utility. So why utility is important? Because now you can put something into numbers with this ordinal number. Okay, for example, pleasure, satisfaction, love, faith. Okay, everything you can put into utility. Yeah? So there are two meanings of payoff. Okay, one is the utility that each player will receive after, okay, all player, okay, or nature have picked their strategy, right? This is the consequence after you get do some action. Yeah? All players do some action, then this is the payoff. The second meaning is actually expected utility. Yeah? It's the average utility that the player will receive based on the function of strategy of himself and other players. Okay? So payoff is also called outcomes, right? The outcome of the game is just the set of interesting elements that the modeler pick, okay, from the value of action, payoff, and so on. So that outcome is really depends on you who model this. Okay. Now, later in game theory, we will discuss about equilibrium. Okay, for example, you will talk about Nash equilibrium later. Eh? So what is equilibrium? So equilibrium is a strategic combination, okay, that consists of best strategy for each of the n player. Say if you have two players, okay, the best strategy of row and the best strategy of column, the intersection of these is called equilibrium. So, right? If you know the equilibrium, you know the best action that you can choose. And you also know the best action that the opponent will be able to choose. So that's why our goal in game theory is to find, okay, the equilibrium and its value. Clear, yeah? Okay. So we are trying to maximize the individual payoff. Okay? That means now if given the equilibrium, now you can see what action come out with the conjunction with the plan of the player. Okay, but be careful. In game theory, equilibrium not always exists. Not always exists. Eh? Sometimes exists, sometimes not. And if exists, is not necessarily unique. Okay? There is possibility that you have 2 equilibrium, 3 equilibrium, and so on. Okay. Now, the simplest competitive games is called zero-sum game. Okay. So, in zero-sum game, okay, the total payoff is 0. So, the positive can the payoff can be positive, can be negative, right? Okay, and the total is 0. So that means if you have only 2 players, your winning equal to your opponent lost. Oh, in sport event, it's always like that, isn't it? Okay, if one player win, the other lost, right? Of course. So this is zero-sum game. Okay, that means if you put it into algebra, your winning equal your opponent loss, then you put it on the right side. Yeah, this right side you put it on the left side, so you get minus here. So that means your payoff plus your opponent payoff is 0, isn't it? So in zero-sum game, at least you have 2 players. Okay, the total payoff is 0. That means the payoff of A equal to the negative of the payoff of B. Right? In that case, you can put this payoff into single game matrix. It is possible to have more than 2 players. Okay? Example, in trading, okay, if you play stock in the market, okay, so you have 2 traders, A and B, right? But there is also another one. What is that? Broker. Broker always win, right? So say the trader A, okay, buy at 10, for example. Okay, the seller, okay, earning 9, and then the broker will get 1. Okay, so remember the total is 0. Okay? That is the characteristic of zero-sum game. Here, this is the example of game matrix of zero-sum game. Okay. The payoff, remember, in zero-sum game, the payoff is always for row. Okay? So here, when we said 4, 2, 3, 5, what does that mean? Okay? Miss Row, if Miss Row select A and Mr. Column select C, okay, Miss Row will get 4 and what? Mr. Column will get how much? Mr. Column will get. It's a zero-sum game, right? So if Miss Row get 4, that Mr. Column will get minus 4. Okay? So in here, okay, if Miss Row select B, right, and Mr. Column select D, Miss Row will lose 5, right? Miss Row will lose 5. That means Mr. Column will gain 5. So the positive payoff indicate the payment to Miss Row from Mr. Column. Okay? The negative payoff indicate the payment from Miss Row to Mr. Column. Is it clear or not? The meaning of this payoff matrix. Okay, so we can check. Okay, so how do you select? Okay, easy. Okay, because this is payoff of Miss Row, right? So that means Miss Row will maximize, okay, the minimum row. So the best strategy for Miss Row is to get the minimum row. So for example, A, between 6 and 5, what is the minimum? 5, right? Between 5 and 4, what is the minimum? 4. Okay, and then Mr. Column will minimizing the maximum column. Okay, so Mr. Column between 6 and 5, what is the maximum in the column? 6. Okay, between 5 and 4, what is the maximum? Which is 5. And then it will get the minimum among these two. Okay, Miss Row will maximizing among these two. Okay, so then you can see the strategy will intersect strategy A and D, right? A and D will intersect. So this is the payoff. In that case, the equilibrium is this. Okay. equilibrium is 5 in this case. Okay, so very simple, right? Just maximin and minimax. Okay, zero-sum game is just maximum and minimax. In fact, maximin is exactly the same as minimax. In zero-sum game, okay, maximin will be exactly the same as minimax, which is the same as the game value. Okay, so now if we're dealing with non-zero-sum game, right? So in that case, you will have two payoff. Why? Because in zero-sum game, the gain is equal to the loss. So you can just represent it as one of the player, right? With this row, in this case. Right? But if you have non-zero-sum game, you have two payoff, right? One is for the row, the other one is for the column, right? Because this is two player. Okay? In that case, you will put it this way, comma. Or you can put it in two tables, that's okay. Yeah? So, comma is more brief than two tables. So, we'll say the first number here represents the payoff of this row. The second number here is the payoff for Mr. Column. Is it clear or not? Okay, so in zero-sum game, you have only one number in one cell. In non-zero-sum game, you have two numbers. Okay, if you have one number, you understand the meaning is the other number is there, but actually negative. Right? But now you have non-zero-sum games, you have both sides, okay, for row and column in one cell. Okay, so now suppose this is the game called Battle of Sexes. Later on when we discuss about it, I will discuss the story. But at this point, just look at the numbers. Okay, so this is non-zero-sum game. Why? Look at the number are not the same, right? So then if you want to represent this table into tree diagram, you start with row. Okay, so row have two alternatives, right? Top and bottom. And then now Mr. Column have two alternatives, left and right, correct? And then you show the outcomes. Okay. The first outcome is for the row, the second outcome is for the column. Okay, so you can draw a tree diagram based on the matrix. Yeah. You remember that the tree diagram is more general than the matrix. The fourth component of game theory is information. Okay, so what is this? Okay, the set of player knowledge at particular time, okay, of the values of different variables, okay, that the player thinks are possible. Okay, so player information can include distinction between the values of variable, for example, the strength of the demand, okay, or the knowledge of what action has been taken previously. Okay, so information will change over time. Okay, so the information set change over the course of the game. Okay, I'll give you an example of information. Threat. Okay, so information play important role in threat. I give you an example simple. So say you are a kindergarten teacher, okay, dealing with children who misbehave. Okay, so then you tell, if you tell to the children, you are the teacher, so you tell to the children, if you misbehave, I will tell your parent. Right? If you misbehave, you threaten the children by saying, if you misbehave, I will tell to your parent. Okay? But look at the fact. Okay, most grade school teachers actually have self-interest, okay, for not informing the parent about the children misbehave, isn't it? Right? Why? Because it will upset the parent. Okay, and the teacher also realized that the children bad behavior is probably the teacher's fault, isn't it? Right? Right? So it's not within the self-interest of the teacher to tell the parent that the children misbehave, right? But the children does not know this, right? This is talking about information, okay? Right? The teacher does not know this. So the teacher still threaten the children to behave well, or else will report to the parent. Now, creating the decision tree here, okay? Now suppose if the children knew the teacher's self-interest, of course, the children will not behave. Right? Correct or not? Okay. So the children have two possibilities: behave or not behave. Okay. Now me as the teacher, kindergarten teacher, okay, will have two options: tell parent or not tell parent. Okay. So this is the value of information. Okay. The threat become credible simply because they don't know the actual information about the self-interest of the teacher. Interesting, eh? Yeah, these are just quote. Okay. So what you can learn from game theory, yeah, basically, at least you should be able to learn to think from other people's point of view. Okay. Later on, when we practice a lot in game theory, you start to think about how to put yourself in other people's shoes. In fact, that is the lesson here. Okay. So, is there any question so far? So, in the second slide, okay, this is very short. In modeling game theory, this is the second slide. You can follow from Lentera. Okay. In here, I will just practice. Yeah. Do for yourself. Okay. A workshop. Okay. How to create that matrix. Okay. How to create that matrix, and then what is the meaning of that matrix, and how you develop your own matrix based on the problem. Okay. So I hope you can practice this. Okay? So you already know this, right? A while ago I discussed about what is zero-sum game. Okay, I will just skip this. And this is the example of game matrix. Okay. So now, what do you think about this payoff matrix? If all zero, what is the meaning? If the payoff is zero, what is the meaning? Okay. So we can put all zero here, does not mean that actual gain is zero. Okay. So you should know that the meaning of zero here is representing expected payoff. Okay, that means can be positive, can be negative, but the average is zero. Okay. Okay. So let's practice this. Now, what will happen if you have the game matrix with this 2, 2, 2, 2? Who win here? Row or column? Huh? Row
Row.
win. Okay,
It's
row
positive
win.
for her. Yeah.
Yes, it's positive for her. Okay, so in this case, the column always lose. Okay, no matter what he select, he always get -2. Okay, okay. So of course, the column will not want to enter this scheme. Okay? A while ago, we talked about oil drill. So what is the meaning of this -7 and -5? Can you explain?
The -5 is the basically you lose 5 million if it's in million if
Hmm.
there's oil and you decide to sell equipment. So it's like opportunity loss.
Yeah,
Well, if you drill
opportunity.
and there's no oil, you will lose like 7 million because you expense already, right?
Correct.
But you will gain 10 if you actually have oil in that place.
Okay, very good, very good. Okay, so this is a game against nature. Yeah? The opponent here is not necessarily human. Okay. Oh, now I want you to develop. Do you know rock, scissors, paper game, right? Can you create the game matrix of rock, scissors, paper?
Okay. Wait, sir.
Okay, and then you can share your screen. Rock, scissors, paper.
Use numbers or like draw, win, lose.
It's up to you. Oh, okay, very good. Okay, so now if you put draw as 0, lose as -1, eh, it's okay, you can copy that, okay. And lose is -1, then you also have uh, the value, okay, in utility value. Okay, so because this is utility, okay, so you can also put not necessarily -1, right?
Oh, utility.
Yes, correct.
Yeah.
So you can put any numbers, right?
Yes.
Example, uh, loss is 0, draw is 5, okay, and then win is 10, is the same. Same,
Yeah.
okay? So that's why the actual number is not important. Okay, the order is important. Okay, good, very good. So next one, I want to show you. This is very nice example. Okay. Here. Say you have two nations working. Okay. Say I have a row and column, and these are the city map and the road. Okay, the road map. Okay, so the path for the row is, for example, passing through B and then go to column, right? For the row is going to B and then directly to the column. Going through B and then A and then C and then go to the column. Okay? Or B and then A, C, D, and then go to the column, or directly A, from A and then B and then go to the column, and so on. So these are, for example, the path for the row. And the column will select only this path, okay? Directly to B, directly to PA, from column, from column B, A, and then row, C, A, and then row, or C, D, and then row, or directly D, and then row. Yeah. So now these are all possibilities. Example, in this example. So my question to you is, what is the size of the K matrix?
9 by 5.
Okay. So the K matrix, okay, representing by all this path. Okay. So 9 by 5. Okay. So this example of the number that you can put in here. Okay. So what is this number? Okay. For example, -8 here. That means if the row use BAC path, right, and the column use BA path, then the column win 8 and the row lose 8. Clear, yeah? Is it? So from the game, the real games, you can show the path and then all the alternative, and you can start to see how you create the K matrix. Okay, the same thing here. If 3 near mean, if the row choose D, C, A, B, and the column choose C, D, the path, okay, and then the row will win 3 and the column will lose 3. Is there any question? Clear or not? Divi? I cannot see you. Okay,
Yes, sir.
yeah. So, is it clear, Divi?
Yes.
Okay. So, this is another example of a mousetrap. Okay. So, this is a mouse and cat game. Okay. So, I just draw in Visio. Okay. So, the cat and mouse will enter a blind maze. Okay. So, these are the blocks that we put inside. The cat will enter from here. Right? Where is the point? Yeah, the cat will enter from here. Okay. And then the mouse will enter from this. Okay. And they may turn into corner but cannot turn around. So they cannot go back. Okay, that's the rule. Because it's very narrow. Okay. So they also travel at the same speed. Okay. So they are given enough time to cover 1/4 of the maze. Okay, meaning 3 consecutive steps. After that, the mouse will be rescued if still available. Okay, otherwise mouse is dead. Okay, so now my question is, can you develop all possible pure strategies, all the possible action to create game matrix of this game? Only 3 steps.
The goal is to enter and go out, right?
To end the 3 of them go at the same speed, okay, and then only 3 steps. Okay, within 3 steps, if the mouse is cut by the cat, the mouse dead. Okay, in 3 steps, if the mouse still alive, the mouse will be rescued by the human.
Oh.
So, okay, think first before we discuss the answer. So do you understand the problem? You need to create the game matrix. Okay. Then you need to put all possible action, right? Alternative. Okay. So each of these I'll draw here is this is the all possible uh, pure strategies, the action. Okay. So the cut start from here, right? So 1, 2, 3. So three steps. Okay. The cat can choose this blue, yeah, eight possible values of the blue. The mouse can choose 8 possible values of the mouse, the red one. So then the size of the game matrix must be 8 by 8, correct? Okay. Then you can start to create that game matrix. Okay. So let's call this strategic 1 to 8, yeah, for the cat and for the mouse, separately. Yeah. I just draw in here in the same two row, but actually they are separate, okay, cat and the mouse. So from there, remember the cat is maximizing, the mouse is actually minimizing. So this is what we have. So this is the payoff for the cat. Okay. One mean the cat cuts the mouse and the cat win. Okay. 0 mean the mouse still alive. Can you see that or not? 0 the mouse still alive after 3 steps. And number 1,
It's unfair. Yeah. It's like unfair because the cat has a really high chance of winning.
yeah, correct. Okay. The point in this practice is you can practice on your own later in the house. You check that based on this game alone, you can start to create the game matrix. That's the point here. Okay. Developing the game matrix is very important steps. Okay, so that you can apply game theory in your daily life. Right? To be able to apply game theory in daily life, you should be able to create the game matrix first. Correct or not? Okay? Your own game matrix based on your own situation. Okay? Then after that, the computation is purely technical that we can discuss in the class. Okay? So, in your practice, okay, this is a while ago, right? The rock, paper, scissors. Okay, you can modify. Okay, can you modify the rock, scissors, paper game? Okay, so that here, if you win using scissors, you get 3 points. If you win using rock, you get 2 points. If you win using paper, you get 1 point. If you lose or draw, you get 0 points. And can you create a game matrix of row and columns? So, can I give you this as your assignment? You see, right? Just one game matrix.
Okay, sir.
Okay?
Yeah. Okay.
It's just to practice, huh? So that at least you know how to apply game theory in your life later on, even though it's only rock, scissors, paper. Okay, so this is okay. So until rock, scissors, paper. So our lesson. This game theory part that in the afternoon session is not part of the midterm. Okay,
Exam.
but the
Okay.
morning is included. Okay.
Okay, sir.
So our exam is in Lentera. You know the date. Wednesday,
Yeah. Wait.
Wednesday 30 March 9 to 11.
Yeah, Wednesday. Okay.
Okay, good. So see you after the midterm then.
Okay, thank you, sir. See
Okay,
you.
bye-bye.
Yeah, thank you, sir.